Ionic
The
bond.
ionic bonds. We understood this in the last time, right? And why are ionic bonds formed? By the transfer of electrons. Why does the transfer of electrons take place? Because the atoms, they want stability. What is stability? To gain the electronic configuration is that of the nearest noble gas. And in
Hmm.
order to do so, they either lose the electrons, which are called as metals, or they gain the electrons, which is called as non-metal. Yes.
Yes. Yes.
And in doing this, losing or gaining of electrons, they form the bond. They form the
Hmm.
bond, and therefore the compounds which are referred to as the electrovalent or the ionic compounds, the ionic bond or the electrovalent bond. Why? Because they've been formed by the combination of the ions. Clear? That is
Yes.
what we saw. Hmm. And these are the electron dot structures. So sodium is giving one electron to the chloride at ion, to the chlorine atom to form the chloride ion, and then sodium plus will bond to chloride minus, right? That is Cl minus. And what force is present between these two? Cations and anion.
Ionic force.
Very good. What is that ionic force?
And the combining
Hmm.
of ions. Combining of the ions.
Yeah. What force? That any name for that specific force?
Electromagnetic force.
Electrostatic, बच्चे, electrostatic.
Electrostatic force.
Electrostatic force of attraction. Electrostatic force of attraction.
So,
The very strong force, and because of this very strong force, we have high melting and boiling point for the ionic compounds. They are polar. Why? Because they have positive and negative ions together. They conduct electricity. Why? Because again they are polar. They have mobile ions when they are dissolved in the aqueous form, and therefore they conduct electricity. Yes, everything has been discussed all about.
yes.
What will be the compound of magnesium oxide? Can you tell me?
Compound of magnesium oxide.
Huh. Magnesium oxide. So this is an ionic compound. Magnesium oxide is an ionic compound. Can you tell me the formula for the magnesium oxide compound?
MgO2.
MgO2.
Oh, MgO.
MgO. For magnesium sulfate, leave magnesium sulfate, magnesium chloride,
MgSCl2.
MgCl2. Good. So these are some of the examples. All of that has been discussed. In what type of solvent they are soluble? In what type of solvent they are soluble? Are they soluble in the organic solvents like kerosene or petrol?
No.
No, they are not soluble. They are soluble in just the aqueous form, that is water. And it is in water that they dissociate into the ionic forms. Example: sodium plus chloride, Cl minus, and that is when they conduct electricity. Fine. We have to start with the next topic, that is the occurrence of metals. Occurrence of metals. Let's see if Arfa and Afshin are joining, else we'll start with this. Saad, have they shown the marks for the exams which was recently conducted?
Yes, me.
How is the performance?
50%.
50%?
Hmm.
As in, you are telling me for chemistry or for overall science?
Overall.
In chemistry, if I ask you specifically about chemistry, is that any possibility that you can tell me?
No, ma'am, I don't. I remember them. I didn't see the chemistry ones.
The questions were in the mixed format, or were they given separately in the physics, science, biology, like physics, chemistry, biology, different sections?
I'm fixed format.
Huh?
Fixed format. Like first physics, then chemistry, then bio.
Huh. I mean, separate sections, right?
Yes, ma'am.
Okay. So, what has caused you the most trouble? Was it physics, chemistry, or biology?
Physics, ma'am.
Physics. If I ask you about how was the chemistry paper, don't tell me the marks, but just tell me how did it go? What would you say?
It was good. Understand.
No, the paper was good or not?
Yes, ma'am. Paper was good. I understood the questions, but
Mm-hmm.
some points were left, which I have to write here.
Hmm. Okay. Fine. So basically, it was the physics which has led to this 50%, huh?
Yes, ma'am.
Again, practice. What was the problem with physics, if you can tell so?
इसमें
What happened with physics? What was the problem with physics that you faced?
I don't remember like
I mean, otherwise, what problem are you facing in physics? Why such performance in physics? My question is that.
I don't know.
Fine. No. Zebunisa, are you there in the class? Please turn on the camera and the mic.
Um,
Hmm. How was your exam, Zebunisa? You recently
mm,
had it, right? On the 14th or the 15th, something like this.
yeah, supposed to be.
How did it go?
It was good.
It was good. Fine. Whatever we discussed in the last moment, was it there?
Yes.
Were you able to do that? Attempt it?
They asked about bleaching powder
Okay,
and
they
subs.
asked
I
bleaching
must.
powder. Please
Physics
say.
was very.
Physics was very difficult.
Yes.
But you see, the point in physics is understand the concept because you have the graphical data, right? You must, all of you must be having the graphical data in physics. Understand the concepts. Very important. If you have not understood the concept in physics, you just cannot solve anything in physics. Understand, and how will you actually better that understanding? Just by practicing. Just by practicing. And my advice to you would be, I mean, you will have such great teachers for physics here, but if I can give you one advice from my side, is stick to the NCERT first. Go through each and every example, each and every graph, each and every diagram, each and every description, each and every question within the topics and after the chapter has finished in the NCERT itself. Practice all of that twice or thrice at least, and then move on to any other book. Okay. Follow this, and inshallah, hopefully, it should help you. Fine. Both of you, the camera's on. We are starting the next topic.
Yes, ma'am, 1 second.
Fine. Now, if I ask you to define metals in 1 or 2 lines, what is metal then? In simple words. The metals are elements which have a tendency to lose electrons. We saw that to form the cation, huh? Which have a tendency to lose the electrons. Yes, Sad, we saw this right now. And second is
yes,
that
yes.
metals have certain properties. Examples, they are good conductors of heat, electricity, they are malleable, they are ductile, they are sonorous, they are lustrous. All of these are properties which belong to the metals category, right? Now, where are they found? Occurrence means where are they found? How are we able to get these metals? Because whatever metals we are having, we are not getting it, we are not preparing them. We are actually extracting them. Okay, so where are they found? And that we call as the metallurgy. What is metallurgy? Metallurgy is nothing but the metallurgical processes, they are nothing but the extraction of metals from where they are found. Okay, from their ores. So let's quickly discuss ore. Okay, let's quickly discuss ore. It's a very important topic. Please pay attention. Extraction of metals, or basically occurrence of metals. Okay. First point, they are found in the ores. Naturally, in the Earth's crust, some metals are found. Okay. And in what manner they are found? They are found in the form of ores. Now, what are ores? First, let's understand what is a mineral. What is a mineral? Metals are found in the Earth's crust in the form of mineral. What is a mineral? Example, let's suppose sodium is a metal. Okay, sodium is a metal. It will not be found in the Earth's crust just as sodium, but rather it will be found as sodium in some compound, let's say bonded with chlorine. So it is found in the form of sodium chloride. Sodium chloride is found in the Earth's crust, and we can take that sodium from that sodium chloride. Are you getting that? That thing is called as a mineral. That thing is called as a mineral. We have seen the rock salt. Have you all heard about the rock salt? Yes? Yes or no? Any one of you have heard about the rock salt? Saad, you must have heard of it.
Um,
Where are you from, Saad?
yeah,
Where are you from?
Pakistan.
Pakistan is one of the largest producers. They have a largest this thing concentration of rock salt. They produce the largest amount of this. They purify it. You know that whatever rock salt that we are getting is from this, the Pakistani rock salt. Okay, so you must know about it. Now see what is happening. Rock salt is nothing but NaCl, huh? NaCl with some other compounds as well, elements in it. And if we are having it like this, we can extract sodium from it. Yes or no? We can extract sodium from this compound. So we can get the metal which is sodium. Fine. Now this is what we mean by minerals. Now what are ores? What are ores then? Minerals which can be used for the commercial purpose, which could give us metals for a profitable range. That is called as ore. Ores, minerals which could be used profitably from a commercial point of view, that from which the metals could be extracted, giving us a lot of profit. That is called as ore. That is called as ore. Why are we saying that we need to have ores and minerals differently? Because let's suppose when we are having a metal, okay, we are extracting a metal, we are putting in a lot of energy, we are putting in a lot of money, okay, and it is not giving us the return as we were expecting it to be, the amount of energy and money that has been put into. So there is no use of extracting that, okay. So we want to find minerals from where, using the same amount of energy and money, the metal could be extracted in a large quantity. Therefore, we do not really extract metals from the minerals, but rather we extract metals from the ores. Right? Now, can I say all ores are minerals? Tell me, is this statement correct or not? Okay.
Yes.
All ores are minerals. Okay. But can I say all minerals are also ores?
No.
No.
No. If I say it like this, all minerals are not ores. Now is it correct?
Yes.
Therefore, all ores are minerals, but not all minerals are ores. Okay. Not all minerals are ores. Fine. Now see. We have three major steps. We have three major steps in extracting the metal from its ore. Three major steps of extracting the metal from its ore. Okay. First is the concentration of the ore. Wherever you have any problem, please ask. Concentration of the ore. Okay. Once we have concentrated the ore, again the same purpose, that we are able to get the compound in which we are having the metal, because it's better to extract it from that ore. We are not using the energy for the impurities. We're just using the energy to extract the metal from the ore itself. That's the compound. Fine. The second is, once we have got the ore, okay, we can extract the metal from the ore. Extract the metal from the ore, yes or no? And the third is, once we have got the metal in the second step, okay, we can refine the metal to have it free from the impurities. Is it clear? These are the three steps that we need to follow. These are the three steps which are present in the metallurgical processes. Now see, all of these steps basically are dependent on 3 to 4 factors. What type of ore is there? What type of metal is there? What is the nature of the ore? So all of these things decide all of these steps. Right? Now, in our syllabus, we have the main step, that is the second step, that is the extraction of.
Concentration of ore. What is concentration of ore?
We are coming to that. We are coming to that. Okay. So, but in our syllabus, the second and the third step is there mainly. The first step is not talked about much. So let's quickly see. That is the concentration of the ore. Concentration of the ore. Fine. So basically, let's suppose you are having ore, okay, and in that you will be having the dirt, the other particles, some of the other ores, okay, a concentration of different ores. So what we'll do is that we would want to concentrate on one, compound. Let's suppose a very random example. Let's suppose we are having sodium chloride, aluminum oxide, sodium sulfate in some amount, but the major part is the sodium chloride. We are having dust particles, also different things. What we would want to do is that we would want to concentrate on the sodium chloride, sodium chloride, sodium chloride. Once you have concentrated the sodium chloride, then we can extract the sodium metal from here. Yes. That is the same thing, that is concentration of the ore. Okay. Basically, we are removing all other impurities, all other compounds present there, so that we can have the concentrated form of the ore through which we can extract the metal. Is it clear? Yes or no?
Yes.
Yes.
And that, what is it called as? The impurities here removed here, bache, are called as the gangue. Gangue. Okay. GANGUE. Fine. Once we have concentrated the ore, we have the ore in which the metal is present. We have the ore in which the metal is present. We need to extract the metal from that. Okay. Now the second step, that is the extraction. This is very important. Please pay attention. Extraction of metal from ore. Tad, are you even getting this, bache? Or is it too boring? Is it too boring? Please pay attention. See, this we do on different types of metals. Okay, this is based different reactivity of metal. What reactivity of metal? See, please recall the reactivity series. We have the reactivity series, and we can generally divide all the metals present in the reactivity series in three major categories. Okay. One is the most reactive metal, or called the highly reactive metal. Okay. Most reactive metal or the highly reactive metal. Okay. Can you tell me the examples here for these?
Potassium.
Sodium, potassium, calcium, magnesium, right? Good.
Yes.
Sodium, potassium, calcium, magnesium, right? Then we have the second one, which is moderately reacting metal, right? Examples are for the moderately reactive metals, bache.
Neon.
Huh?
Neon.
Neon. Are you
Hmm.
just saying neon? Neon is an inert gas, bache. See,
Zinc.
iron, good. Aluminium, zinc, okay. Copper at times. So all of these are examples of nothing. Lead, okay. All of these are examples of the moderately reactive metal. The third one is the least reactive metal or very less reactive metal, okay. Uh, silver, gold, okay. Uh, Copper, at times copper is taken in the least reactive metal category, okay. Mercury, all of these are examples of platinum. All of these are examples of the very least reactive metal. Fine. So the extraction of the metal from their ores is based on this. Yes, they're going to say you have a question. Huh.
Ma'am, carbon is most reactive metal.
What is more reactive metal?
Carbon.
Carbon is a non-metal. Basics. Fine. Carbon is a non-metal. But we are talking about the extraction of metals, okay? Not the non-metal. Metals are found in this way. Fine. Is it okay? Everyone of you clear? Now see, I'm coming about, we are going to talk about the extraction of metals from their ores, and what category we are going to talk about, the most reactive metals or the highly reactive metal. Clear? Generally, I'm saying generally these are found in the chloride form. What form? The chloride form. So sodium chloride, the potassium chloride, the calcium chloride, the magnesium chloride, the aluminum chloride. Okay. All of generally, I'm saying mostly they are found in the chloride form. At times they can also be found in the oxide form. Okay. At times they can also be found in the oxide form. So let's suppose if I'm having it like this, sodium chloride, okay. Please recall the redox reaction here. Sodium is in some oxidation number here, some oxidation state here, that is +1. If you are able to reduce sodium, and we'll take, how do we reduce sodium? Simple here, we'll take the chloride from the sodium here, okay. We'll be taking extracting the chloride form, and sodium will get reduced, okay. Basically, we want something here. Let's suppose I take anything here, potassium, any random example, I'm giving this to you, okay. Potassium will react with chloride, and sodium will be reduced. Yes or no? Sodium will be reduced. Yes or no? No. Is sodium reduced here? What is reduction? You both need to respond. Otherwise, I keep on saying And that's it.
Reduction of oxygen from an element.
Removal of oxygen from an element in the compound. Huh? That's the basic definition. That's right. Other is the losing or the gaining of electron. If the element is present in some bond in a compound, that means it is in some oxidation state because it is losing electrons. Whereas here, it is just present in the elemental form. So here it is in zero oxidation state. Therefore, it has been reduced from +1 to 0. Fine. Okay. So basically, we need to reduce the metals. We need to reduce the metals from their ores. We need to reduce the metals from their ore. And one of the most important reducing agents that we'll be using in further experiments, further these thing reactions is carbon. But we cannot use carbon for the most reactive metals. We cannot use carbon for the most reactive metals because they have such high affinity for oxygen. Because they have such high affinity for the oxygen. Okay. So what do? We do electrolytic reduction. What do we do, Bachu? Electrolytic reduction. Electrolytic reduction. What do we do in the electrolytic reduction? First, we take the ore in the molten form. What form? Molten form. Why molten form? Because in the molten form, the ions will be mobile. They'll be moving. Okay. They'll be moving. And please know that we are using the electrolytic reduction. We need the electricity to be there. Electric current will be passed. And why will that be electric current passed? Because, and how can that electric current be passed? Because when the ions are in the moving form, that is when they are in the mobile form. So see here, we take here the molten NaCl. We take it example NaCl. Okay. We take NaCl in what form? Sad in what form, bache?
Milton.
Molten form, huh? Molten form. Okay. We take it in the molten form. That is semi-liquid. Fine. We take it in the molten. We have the electrodes here. Okay, we have the electrodes here. Here we have sodium chloride, molten form, liquid. Fine. What will happen? Cathode, which is negatively charged, anode, which is positively charged. Don't you think sodium will get deposited on cathode? Sodium will get deposited on the cathode. Why? Because sodium is positively charged here and cathode is negatively charged here. Yes or no?
Yes.
And the chloride gas, chloride ion will get deposited on the anode as the chlorine gas. So are we able to extract sodium from the sodium chloride? Yes or no? We can have the sodium which is present on the cathode. We can take that out. What we'll get? We'll get pure sodium. We'll get pure sodium. Yes or no?
Yes.
Not clear. Debunasa, is it clear to you? Right. So we'll quickly see through the NCRT. What type of metals are these which are reduced through the electrolytic reduction?
Most reactive.
Most reactive. Very good. Okay. See. The metals at the bottom of the Earth's crust is the major source of metals. We already saw that. Seawater also contains some soluble salts such as the sodium chloride. Again, do we use the desalination method? We have the seawater, we take that, okay, we let the water to be evaporated, and what is left behind is the salt. Okay, is the salt. And that salt is sodium chloride. So we can extract the sodium from the chloride form. I mean the sodium chloride. Magnesium chloride. The elements of the compounds which occur naturally in the Earth's crust are known as minerals. Okay. At some places, minerals contain a very high percentage of a particular metal, and metal can be profitably extracted from it. These minerals are called ores. I hope no confusion in this paragraph.
Yes.
Fine. So the next thing is extraction of metals. Reactivity series is very important. Having some metals are found in the Earth's crust in the free state. What metals are these? Which are very less reactive metals. Okay, almost non-reactive. Example: silver, gold, platinum. They're found as it is, just in the native form, without being in combination with anything. Just 1 second. Yes, okay. Now, they are often found in a free state. Silver, gold, platinum, and copper are found in the free state. Copper and silver are also found in the combined state. We just now saw this in their sulfide or the oxide form. That's it. Now, coming on to the next part. See. Extracting metals towards the top of the reactivity series. Okay. The metals high up in the reactivity series are very reactive. They cannot be obtained from their compounds by heating with carbon. See, what is the use of carbon here? Generally, carbon is used as the reducing agent. What is it used as? The reducing agent. But since these metals are so highly reactive that carbon could not be used with them as a reducing agent because they have such high affinity for oxygen. Okay, for example, carbon cannot reduce the oxides of sodium, magnesium, calcium, and aluminium to the respective metals. This is because these metals have more affinity for oxygen than carbon. Is this point understood or not? Let's suppose this. This is sodium oxide. I want to extract sodium from the sodium oxide. If I react it with carbon, let's suppose what happens. So carbon plus oxygen, carbon bond with oxygen, and what is left here? Sodium metal, right? So in this manner, we can get the pure metal. We can get the pure metal here. But this is not possible. Why? Because the sodium does not even leave oxygen here. Because sodium will bond to oxygen much more strongly than carbon will bond to oxygen. Are you getting this? Fine. These metals are obtained by electrolytic reduction. Sodium, magnesium, and calcium are obtained by the electrolysis of their molten chlorides. Again, I use the same thing, the molten chlorides. Okay. What do we mean by the chlorides here? Molten chlorides here.
Chlorides in molten form.
What are chlorides then?
Molten form.
What are chlorides? What is referred to, like what do we mean by chlorides here?
Most reactive metals.
Huh?
Most reactive metals.
Most reactive metals, but why chlorides? Chlorine is not a metal, it's a non-metal. Chlorides here is referring to the ore in which they are found. Okay, the chloride ore, the sodium chloride ore, the magnesium chloride ore. Okay, the chlorides here refer to that ore in which these metals are present. I just now told you that these metals are generally present in the chloride ore. Yes or no? No.
This one.
Fine. Okay. The metals are deposited at the cathode. Very important question. Again, one more question. In the electrolytic reduction, on what electrode is the pure metal deposited? That is the cathode. Metal is deposited on the cathode, whereas the chlorine is deposited on the anode. The chlorine is liberated at the anode. Okay. The reactions are the important reactions. Very important. See, Na is in the positive form, right? We know NaCl. What is the formula for NaCl? Na plus Cl minus bonded together. Yes, sir. We saw this in the last class. So Na plus, if it is dissociated, don't you think Na plus will go to cathode? What is cathode? It is having electron. Cathode is having electron because, huh?
Electrons.
Yes, cathode is having electron. So it is negatively charged. So the sodium plus will take the electron from here and will change to the sodium atom. Yes, see, this is what is happening. Sodium plus one electron will give you sodium atom. Yes or no?
Yes.
And what is happening at anode? Anode is positively charged. So the chlorine will be actually losing the electrons there. And these two will be combining together Cl2 to give you 2 electrons. Is it clear? The reactions are clear? Fine. Any problem? Bacho, please listen attentively. And if there's any problem, please ask. Aluminium is obtained by the electrolytic reduction of the aluminium oxide. The similar manner. Okay, oxygen will be deposited on the anode, and on what electrode will aluminium be deposited here? For the electrolytic reduction of aluminium oxide, on what electrode will I get aluminium?
Any metal which is more reactive than aluminum?
My point is, let's suppose I have aluminium oxide. This is the ore here. This is the ore. Oxide ore it is. What type of ore it is? It is the oxide ore, right? Not the chloride ore, because it is in combination with the oxide. Fine. I take the molten form of this. I go for electrolytic reduction. Okay. When electrolytic reduction will happen, definitely there will be 2 electrodes, cathode and the anode. And on one, aluminium will be deposited. On the other, the oxygen gas will be deposited, right?
So,
My question is, on what electrode will aluminium be deposited as a metal? I've given you the answer right now.
oh, cathode.
Cathode. Good. Very good. The metals will be deposited at the cathode. Just simple logic here. Cathode is a negatively charged electrode. The metals are positive. The metals are positively charged. Therefore, metals will be attracted to the cathode. Excellent. Fine. So we have got the metals which are most reactive in this reactivity series. We have extracted the metals from their ores. Let's come on to the next type of metals. What are they? The moderately reactive metals. Okay. The moderately reactive metals. Any example here? Can I take zinc? Can I take iron, aluminium, at times copper? Okay, all of these are examples of these. Fine. See, generally they are found in the, please pay attention, generally the sulfide ore, I'm saying either in the sulfide form or carbonate form. That is the sulfide ore or the carbonate ore. The sulfide ore or the carbonate ore. Fine. And this is very simple. The method is very simple. What do we need to do is that we first change it to the oxide. We first change to the what form? The oxide form. What form are they found in? They are found in the sulfide or the carbonate form. What do we change it to? We change it to the oxide form. What do we change it to?
Oxide form.
Oxide form. Once we have changed it to the oxide form, we can reduce it. What do? Reduce it. We get the metal here. We get the metal here. Then see, what do we do? Let's take the example. First, we'll be taking for the sulfide. Okay, zinc sulfide. But so this is one of the ores for this zinc, and this is called as zinc blend. Zinc blend. I'll give you the name of some of the most commonly used ores. Okay, this is zinc blend. Blend. So this is zinc sulfide. Now I want to extract zinc from this. I want to extract zinc from this. Yes. What do I do? First, I will change it to zinc oxide. First, I will change it to zinc oxide. And then from zinc oxide, I can reduce it to get zinc, right? I can reduce it to get zinc, yes or no? Fine. So let's see how does this happen. Whenever the sulfide ores, please pay attention, Revenue the camera on, sulfide ores are changed to oxides, we use roasting. Roasting. What is roasting then? Heating sulfides in presence of oxygen. In presence of oxygen. Let's see this, bacho. This is zinc sulfide. So I will heat it in presence of oxygen. What will it change to? It will change to the zinc oxide. It will change to zinc oxide. Fine. Once it has changed to the zinc oxide, I will need a reducing agent. I will use carbon as a reducing agent. What am I using here as a reducing agent? What is this, bacho? Carbon, okay? Carbon used as a reducing agent. What will I get? Zinc plus carbon monoxide. You can see here from zinc oxide, I've gotten pure zinc. Yes or no?
Yes.
That's it. Reducing agent. Obviously heated in the presence of carbon. Okay. That's it. Is it clear? Let's suppose I have taken any this thing, carbonate. Okay. Let's suppose I've taken any form of carbonate. Change to oxide. In absence of oxygen is called as calcination. What is it called as? Calcination. Fine. Let's suppose I have this. I want to take some example which is having carbonate. Let's take the example of zinc carbonate. Okay, zinc carbonate. This is in a carbonate form. What do I need to change it? Since it's a moderately reactive metal, first I will have to change it to the oxide, right? I will just heat it, but absence of oxygen. What will it change to? Zinc oxide. Once I have gotten the zinc oxide, I will reduce it using carbon again. Okay, what will I get? Zinc plus carbon monoxide. Same. Have I gotten the pure metal? Yes, I've gotten the pure metal. I think it should be clear. Clear, bachcho? Done.
Yes,
So
sir.
basically, what is the basic difference between calcination and roasting? Roasting means heating the sulfide ore in presence of oxygen to get the oxide form. That is roasting. What is calcination? Heating the carbonate ore in absence of oxygen to get the oxide is called as calcination. Clear? Should I repeat this, Sir?
No, ma'am.
Fine. Done. Written. That is calcination. Once we have done the roasting or the calcination based on what type or what type of ore we had, we get the oxide. And once we have got the oxide, we can reduce it using carbon as a reducing agent. And what we will get there? What we will get there is that we will get the pure metal and the carbon monoxide there. Okay, we'll get the pure metal and the carbon monoxide. Clear, bacho? Fine. Moving on to the next point. The third one is the least reactive metals. They're generally found in the free states. We just now saw. They're generally found in the free state, right? Which is the native state. That is without any bonding. You must have heard of many, news that we get that gold is found like as it is. When digging, gold was found. Why is gold found as gold as it is? Because it is not found in any combined state. Okay, it is not found in any combined state. It is a very, very less reactive metal. It will not really combine that easily. So therefore, we get gold as it is. Are you getting the difference here? Right. So see, if they are found in some, carbonate or the sulfide form, let's suppose we have some metal, less reactive metal, which is found in the sulfide or the carbonate form. Okay, if it is found in the sulfide form, again roasting, and it will change to the oxide form, right? If it is found in the carbonate form, what will happen? What is that we'll do? Calcination. Calcination, okay, it has changed to the oxide form. Once it has changed to the oxide form, we will simply heat it without having carbon there. We will simply heat it without having carbon there and the metal will be produced. Why are we not using carbon? Why are we not using carbon here? Any idea? Carbon is not used here for the very less reactive metals for the reduction because they are such less reactive metals that they get reduced simply by heating. We don't need any reducing agent as such, okay? So carbon not used as these metals on simply heating, okay? Reducing agent is not required. Reducing agent not required. Fine. Done.
Yes, ma'am.
Let's quickly go through the NCERT here. Okay. The metals at the top of the just 1 second. See, the metals at the top of the activity series, that is, these are so reactive that they're never found in nature as free elements. This is very obvious that they are so reactive, okay? The metals in the middle of the activity series, zinc, lead, iron, are moderately reactive. They are found in the Earth's crust mainly as oxides, sulfides, or carbonates. If they're found as oxides, we can simply reduce them using carbon as a reducing agent. If they're not found in this oxide form, what we'll do? We'll change it to the oxide form. And what are the different methods by which we can change it? Roasting and calcination. Okay,
Calcination.
good. The ores of many metals are oxides. This is because oxygen is a very reactive element and is very abundant on Earth. Important point. Yeah. Fine. Next one. On the basis we can have it. Fine. Enrichment of ores has been done. Now see. Extracting metals low in the reactivity series, fine. Metals low in the reactivity series are very unreactive, can be reduced to metals by heating alone. We just now saw that we don't need any reducing agent as such, okay? For example, cinnabar. So cinnabar is this, okay? Is the ore for mercury. Cinnabar is one of the ores for mercury, and in what form it is present? The sulfide form. What form? You can see HGS, right? That is the sulfide form. Is an ore of mercury. When it is heated in air, it is first converted into mercury oxide. Can you tell me what is the method here which would be used to change the HGH, which is the mercury sulfide, to mercury oxide? What is that method? In the presence of air, heated in the presence of air. Ah, something called as roasting. Something called as
Roasting.
roasting. We can clearly see, which is the sulfide ore is being changed to oxide form, right? That, yes or no? That, yes or no?
Yes.
Mercury oxide is then reduced to mercury just by simply heating without any further reducing agent. See, are these equations understood?
Yes.
Then copper sulfide, see, copper sulfide changed to oxide, heated in the presence of oxygen. This is nothing but roasting, bache. Change to the oxide form. Now this oxide form could be simply heated and then change to the copper form. Okay. Any problem in this one? The least reactive metal. Fine. Coming on to the in the middle of the activity series. Iron, zinc, lead, copper are moderately reactive. So you saw that copper is also present here and copper is also present here. Usually present as sulfides or carbonates in nature. We discussed this. It is easier to obtain a metal from its oxide as compared to its. Very good question. Why are we really changing the sulfides and the carbonates to the oxide first and then we are reducing? Why? Very important.
What is the
There
question?
are 2 points. There are 2 points. First, to reduce an oxide is easier than to reduce the sulfide or the carbonate. Ultimately, we need to reduce it, right? So to reduce the oxide form is very easy compared to the reduction of the sulfide or the carbonate form. That's the first reason. Second, if let's assume we are able to, manage the reduction of the sulfide or the carbonate, what we'll get is the byproduct other than the metal that is that is very difficult to manage. While we were reducing the oxide, we were getting carbon monoxide, yes or no? While we were reducing the oxide, are we getting carbon monoxide? And it is easier to manage carbon monoxide in comparison to something that we'll get when we'll reduce the sulfide or the carbonates. Is the reason clear? Fine. See, therefore, prior to the metal sulfides and the carbonates must be converted into metal oxide. The sulfide ores are strongly heating. This is called as roasting. This is called as calcination. The chemical reaction. I've already discussed this. Any problem here? See, zinc sulfide present heated in the presence of oxygen, change to the zinc oxide, which is roasting, and this roasting, and this is calcination. Can you see oxygen here but no oxygen here? That means in the absence of oxygen. So calcination. The metal oxides are then reduced to the corresponding metals by using suitable reducing agents such as carbon. Fine, that's it. We get carbon monoxide here. What is the byproduct of the reduction? What is the byproduct of the reduction of the moderately reactive metallic oxide? What is the byproduct of the reduction of the moderately reactive metal oxide? What is being reduced here? Moderately reactive metal oxide, yes. Actually, you people are very disappointing, huh? Zinc oxide, moderately reactive metal oxide, okay? If you reduce it with carbon, what are we getting? One is the metal, which is our main product. The other byproduct is carbon monoxide, right? So carbon monoxide is the byproduct. In the gaseous form, you can see in the gaseous form. Metals in the solid form. Fine. Obtaining metals from their compounds is also a reduction process. I already explained you this. Besides using carbon to reduce, which is nothing but coke, to reduce metal oxides to metal, sometimes displacement reactions can also be used. Just telling both of you, are you in the zone to understand this reaction as of now? or should I continue in the next class? Because I'm not getting the response here. Tell me it honestly, because else I'll continue and I'll not repeat it in the next class then. I want the response then. Either at least respond to this one. Say something.
Yes.
We'll continue then. Bye. See, this is a very important reaction that we'll be learning about. Basically, we need to reduce, right? We are ultimately reducing the ores, the minerals, to get the metals, right? We are ultimately reducing it. I talked it in the beginning also, reducing, okay? And either we are having some reducing agent, example carbon, right? Example carbon. What is the other method that we can use to reduce? Let's suppose this. Okay, we have Fe2O3. It's an oxide of iron. If I react it with a metal which is more reactive than iron, what is it? Aluminium. Aluminium here is more reactive than iron. It will displace iron from its oxide. What we will get? Al2O3 plus iron, right?
Yes,
This
ma'am.
is nothing but a displacement reaction. Displacement. Here also iron is getting reduced. What is it happening? Iron is also getting reduced. But in what method it is getting reduced? By the use of a more reactive metal by a displacement reaction, right? Using a displacement reaction. Now
Yes.
see, this specific reaction, which is the reaction of aluminum oxide with the the reaction of the ferric oxide with aluminium to give you the aluminium oxide and iron, is a very important process, and it has a name which is thermite reaction. What is this reaction called as? Thermite reaction. And this reaction is highly exothermic. That means a lot of energy would be released here. Yes, bacho? And this high energy turns this iron metal, which is reduced, see, which is found here in the molten form. Okay. Energy changes iron from solid to molten, from solid to. Now this reaction is used, was used, not now, earlier was used to join the railway tracks, right? You see those railway tracks? Basically what happens, we use this reaction, we have the ferric oxide, we react it with aluminium, then we get the iron there, and because of such high energy produced in the reaction, the iron forms the molten iron, right? And that molten iron is used to join the tracks of the railway track. Is it understood?
Yes, ma'am.
What is the name of this reaction?
Thermite
Thermite
reaction.
reaction. Very good. See, we'll quickly go through this. The highly reactive metals such as sodium, calcium, and aluminium are used as reducing agents. Okay. Because they can displace metals of lower reactivity from their compounds. I think this is simple displacement reaction. Please understand. For example, when manganese oxide is heated with aluminium powder, what will happen? Aluminium will displace manganese from the manganese oxide, and it will form the pure metal, which is manganese plus aluminium oxide plus heat. Right. Now the next is very important. See, these displacement reactions are highly exothermic. I cannot use the marker. It is having some problems, so please pay attention here. Okay, highly exothermic. The amount of heat evolved is so large that the metals are produced in the molten state, right? In the molten state. These are exothermic reactions. The metal which is produced will change to the molten form. In fact, the reaction of iron 3 oxide, which is ferric oxide, with aluminium is used to join the railway tracks or cracked machine parts. This, why is it used? Now you know, because iron in the molten form could be used that way. Yes or no? Clear. That's it.
Yes,
Is
ma'am.
it fine, Bacho? Is it fine? The next topic is the refinement of the metals. The refinement of the metals. Should I continue that? Raj will answer. Raj, should I continue with that?
And we have 5 minutes. Can we
Yes.
complete in 5 minutes?
No. Then I'll take extra 10 minutes. I'm stopping it here, but uh, my request would be, my suggestion would be, advice would be, please go through these topics. So that in the next class, inshallah, when we are going through the electrolytic refining, that's a very small topic, will take 10 to 15 minutes, that's it. And after that, inshallah, we'll start with the chemical properties of metals and non-metals, which is very important, right? So please go through this. I hope that you will go through all of these topics which have been discussed today. Yes? No?
Inshallah.
Inshallah. Capital letters, inshallah. Huh? Okay, fine. Thank you. Both of you, Melly. Thank you.
Thank you, sir.
Allah Hafiz.